Alright, today we're going to go over our expanded map from class for the hydrology unit. So in the hydrology unit, we talked about streams, our first topic, then we talked about lakes and wetlands, and then groundwater. So let's start with streams. So if we take a look at streams a little closer, we mainly started with the age of streams. So you have your youthful streams, which have that V shape from the fast-moving water where erosion is occurring, and then it's straight most of the time. There's rapids from the large boulders that are in there, and they can carry large materials due to their speed. Now, as they mature, they're going to slow down. They have a U-shaped as they widen, and they begin to meander or bend, and they carry less material because as water slows down, it drops off material. Now, our old rivers are going to be very, very slow, wide, U-shaped. They have meanders and oxbow lakes, which is the cut-off meander, and they carry very little water. Now, they do change from source to mouth. So the source was the beginning, and as you go further from the beginning, it's going to begin to change your river. So it can actually start off as pretty straight and fast moving, and by the time it gets to the ocean, it'll be very wide and have many meanders between there. Now, as it enters the ocean, it creates what's called a delta, so don't forget delta. That's where water enters the ocean and drops off its sediments. Because it slows down. Then you have alluvial fan, where it can be a similar shape. It's usually fan-shaped, but it can also show where sediments are being dropped off as water stops on land. And don't forget the different ways things are carried. You have solution, suspension, and bed load. Solution is dissolved, suspension held up, bed load is rolled. So bed load requires the fastest moving water, and then as you slow down, you'd slow to suspension and solution. Now, lakes and wetlands. The big thing to keep in mind would be that lakes form from glaciers, oxbow lakes, limestone. They can be ancient oceans that have actually been reduced to just a lake as water levels have changed over time. We can make lakes like reservoirs that hold water for human use and things like that as well. And then you also want to keep in mind wetlands and how important they are. Our school was built on a wetland, which is why we have the unique design that allowed for most of the wetlands to be preserved, and so that we can study them in class. And then eutrophication. Don't forget the steps of eutrophication. So we have a little video in class where we watch as nitrogen enters into a body of water. It's going to cause the plants and algae to grow rapidly. The algae covers the surface, which prevents sunlight from reaching the bottom. And when there's no sunlight, those plants on the bottom all die, and their bodies are all eaten up by the decomposers that use up all the oxygen, which then results in everything else dying because there's no longer oxygen in the lake. So don't forget your steps of eutrophication. And then lastly, we covered groundwater. We had the zones, the zone of aeration on the near the surface and then just below, and that's mostly air. Then you have the water table, which marks the top of the zone of saturation, and that's where all your groundwater is held. So that level, the water table level, can go down as the zone of